Okay, so we learned a bunch of different laws. We learned Boyle's law, Charles' law, Gay-Lussac's law. Um, and basically, what they did is they took all of those laws and they combined them, which is why this is called the combined gas law, all into one big equation. Meaning, if you know this equation right here, you really actually know all of the other laws because all of the other laws are embedded in here. So look at, if you're given a problem where they don't talk about moles or temperature, meaning you're assuming that they're constant, that they're not changing, okay? You can see P1V1 equals P2V2. That was the first one we learned. That was Boyle's law, okay? Now, let's say pressure and moles are constant. They don't mention them in the problem. If you cross off the pressure and you cross off the moles, now you end up with the relationship between volume and temperature. This was Charles' law. V1 over T1 is V2 over T2. Okay, and remember, for temperature in this chapter, it has to be in Kelvin. So we'll review how to get to Kelvin again today. All right, and then what's another one? What if volume and moles were constant? Sorry, my computer's having a rough time this morning. So volume and moles are constant. You have the relationship that we learned, the equation between pressure and temperature. P1 over T1 is P2 over T2. Sometimes they do leave out the moles. So down here, wow. Down here is the combined gas law with just the moles not present. A lot of the time, like the majority of the time, to be honest, the moles are considered constant. So this is just a simplified version of the combined gas law, just without N in it. Remember, N stands for moles. Okay. So let's do some practice with the combined gas law, and then I'll show you how to use the combined gas law to do problems that may not use all of the variables. So combined gas law. Now, when you look at this problem compared to all of the other practice problems we had been doing, all of the other practice problems we had been doing had 3 numbers in them, and we were solving for a 4th. Now you'll notice, wow, I do not know what's going on with my mouse, that there's one number here, another number here, another number here, another number here, another number here. There are 1, 2, 3, 4, 5 numbers. So this is probably a good hint that we're going to use the combined gas law, and that's because there's just so many numbers. So let's read it. It says a sample of nitrogen monoxide, and then I give you 72.6 milliliters, so that's a volume, so I have a V1. I give you a temperature in Celsius, so I have a T1. And I give you a pressure, so I have a P1, kilopascals. So what volume? That means V2 is what I don't know. That's what I'm trying to find. Okay. And then I give you another temperature. So that's T2. I'm going to try to plug my computer in and see if it helps. Okay. And 99.3 kilopascals. Remember, kilopascals are a unit for pressure. So that's a P2. So a bunch of P's and a bunch of V's and a bunch of T's is combined gas law. So then you go, okay, well, what is the combined gas law? Well, let's just write it out. So P1, V1 over T1 equals P2, T2 over, P2, V2, excuse me. Okay. Now notice I didn't put the moles in there. Those N's, I did not put them in there. And the question is why? Well, I didn't put them in there because they didn't mention moles anywhere in here. I don't see the word mole. I don't see the letter N in terms of moles. So because it's not mentioned, I'm just going to assume it's a constant. So I'm just not going to place it in my equation. So I'm going to circle what I'm solving for, which is V2. So that's this guy right here. So before I put numbers in, I'm going to rearrange just the variables first. So how do I get the P2 and the T2 over here? Well, I multiply by the reciprocal, right? Which is the same thing as cross multiplying. Okay, that cancels it over here, right? That was the point, so that we can get V2 by itself. And now I'm going to plug in. So T2, that's temperature 2. Now be careful. My second temperature was 24, but you cannot plug in Celsius. So you take 24 and you add 273 to it, and that's the number you can plug in. Wow. So that ends up being, what is that, 297 Kelvin? I don't even know what's happening right now with my computer. This is ridiculous. Okay, 297 Kelvin. P1 is my first pressure. My first pressure was listed at 104.1 kilopascals. Guys, honestly, this is gonna drive me nuts. Okay, so T2, P1, V1 is 72.6 milliliters. Sorry, I kind of ran out, but it's on the top. Divided by P2 is in the bottom, so that's 99.3. This is so bad. And then T1, so not 16, no, you do 16 plus 273. So that's 289. Kelvin. Now, be very careful in your calculator. If you're really good at using parentheses, that's fine. But for me, what I would do in my calculator is I'd hit 297, multiply by 104, multiply by 72.6, and then I'd hit divide 99.3, and then divide again. That's the easiest way to not mess up when you have two things in the denominator. Now, I'm going to look at units. Look at, I have Kelvin on the bottom and Kelvin on the top. I have kilopascals on the top and kilopascals on the bottom, and that leaves me with milliliters, which I'm trying to find volume, so that should make sense. Sig figs, you have, let's see, 3, 4, 3. Now be careful, this is 2 sig figs, yes, but we didn't use 16 in our number. We used 289, and we didn't use 24 in our number, we used 297. Those are 3-digit numbers, so your answer should be 3 sig figs. So let me know what you're getting. I think I have the answer on the next slide. $78.2 milliliters. Questions? Okay. So now this is what I was saying of a type of problem where we're kind of going back now to only having 1, 2, 3 numbers. That last one we had 5 numbers in the problem, which is why combined gas law was good. But here's the thing, this is what I was trying to show you when I first introduced the combined gas law, and I'm going to just show it again. Maybe, if my mouse decides it's going to work. It's my tablet that's the issue. Hold on one second, I'm just unplug it real quick. You're just gonna have to do it like this. Oops. All right, P1 V1 over T1 equals P2 T2. Oh, why do I keep doing that? P2 V2. So if you can just remember this law, the combined gas law, you actually in turn know all of the other laws. So what do I mean by that? So it says what pressure will be needed to reduce the volume of 77.4 heliums, so, or liters of helium. So I have volume, okay? I want to know pressure. I give you a new pressure, 98 is kilopascals as pressure, and I give you a new volume. And the thing that I've completely ignored so far is temperature. So I'm just going to pretend like it's not there. I don't see any mention of temperature. So as long as you know this law, you really know all the other ones. Here is how pressure and volume are related. P1V1 equals P2V2. So let me try one more time to get my tablet to work. So P1 is, you don't know, that's what you're trying to find. Okay, V1 is 77.4, so that's what you plug in right here. P2 is 98, and V2 is 60. So if I want to get P1 by itself, I would divide both sides by V1, right, to get P1 by itself. So V1 goes in the bottom. So 98, sorry, my pad's not working, so I'm trying to use my finger now, times V2 is 60. Divided by V1 is 77.4. So 98, this is a parentheses, times 60 divided by 77.4. And look at, this is liters, right? And this is liters. So the liters cancel and you're left with kPa for the unit of pressure. 3 digits, 3 digits, 3 digits. So your answer is 3 sig figs. And I got 126 kilopascals. Any questions on that one?
Is it okay if I, never mind, I did this last night.
Okay. So let's look at this one now. It says a sample of sulfur dioxide gas has a volume of 1.16 liters at a temperature of 23 degrees Celsius. So, okay, this is a V. This is a T. What temperature, okay, so T2, that's a new T, right? Will the gas have with a volume of 1.25 liters? So again, if you remember combined gas law, so P1 V1 over T1 equals P2 V2 over T2. And then as long as you remember this one, you go, oh, I have a bunch of volumes and temperatures. Who wasn't mentioned at all? Pressure. I didn't see anything about pressure, so I just kind of like cross it off, pretend it's not there, meaning you're just assuming it's constant, that the pressure is remaining constant. And then there is your relationship between volume and temperature. V1 over T1 is V2 over T2. So V1 is 1.16, right? 1.16 liters. T1 is not 23. Remember, you have to add 273 to it. So 273 would be, plus 23 would be 296 Kelvin. V2, my new volume is 1.25 liters. Now you have to be careful. A lot of kids mess this up because T2 is in the bottom. You can't just move 1.25 over to this side and be done. You cannot do that. You cannot solve for this when it's in the bottom. So I'm going to multiply both sides by T2 to get it out of the bottom. Okay, so then it goes away, right? It cancels over here. Now that T2 is not in the bottom, you can solve for it. So you can either do this by multiplying by the reciprocal to get rid of this over here, or cross multiplying. Really, you're doing the same thing. So the 296 comes up top. And the 1.16 goes on the bottom. So look, my liters cancel, and I'm left with Kelvin. So 1.25 times 296 divided by 1.16 will give me my new temperature in Kelvin. Again, 3 sig figs for your answer. And you go, well, why? This is 2. Yeah, you're right. This is 2, but I didn't use 23 in here. I used 296, and that is a 3-digit number. So take a second to calculate it out. So I'm going to end with this one. And you should get 319 Kelvin. Now, if I were to ask you what it was in Celsius, you could just always convert back by taking 319 and subtracting 273, and that's how you would get it back to degrees in Celsius. So turning it to Kelvin by adding 273, turning it to Celsius by subtracting 273. So I'm gonna I'm gonna move your combined gas law worksheet to tonight, which is what we've just been doing, all the gas laws and combined gas laws. Please get that finished. This is where I will end. You can either stay here and work on it. I know there's only a handful of minutes of class left, or you could go ahead and head out. Up to you. Hopefully I'll get my pen fixed.